Hello, this is an Algebra 2 video, and this is a video over Section 7, which is called symmetry. And what we're going to do is we're going to determine the symmetry of a relation from a graph and determine the line of symmetry of a function algebraically. So before we go on, I kind of want to discuss what symmetry is. Symmetry can be thought of as either having some sort of a graph that has a reflection or rotation. Has a reflection or rotation. Okay. And so what we'd like to do is we'd like to look at a very simple example of just a circle. This is a circle of radius 2. And what I know here is that, this circle has a number of lines of symmetry, okay? I can draw a line going down the middle like that, and what I have is that each point here is symmetric on either side of that line, okay? And so we're equidistant from that line of symmetry, all right? And you have a number with the circle. You have like an infinite number of lines of symmetry, but here we'll just talk about a couple. And then it has a horizontal line of symmetry, and so it would be equidistant to all of these points. Okay, and those points are then reflected over that line of symmetry to create those other points. So the other thing that this has is this has rotational symmetry. Okay, we can rotate this figure around, and it will map back onto itself and give us the same figure. So we're just going to kind of explore that and kind of take a look at some of those things. So on this one, it says, this question says, which graphs have a line of symmetry? Check all the boxes that apply. So here, is there something, and the way I kind of think about it is, can I cut this in half? Okay, can I take this and cut this graph in half so that each point is equidistant from that line of symmetry? Okay, and in this case, we have a horizontal line that goes through this, what looks like a sideways parabola. Okay, on this one, it looks like we could potentially put a line of symmetry, which like right about here, because I noticed that, but this point here is a little bit higher than this point. So I would think to maybe put one right here, but the problem is that if I were to go equidistant this way, then I don't get a point over here. Okay, so this has none. Okay, no line of symmetry. But then the last one, notice that we have this curve here. I could draw a line of symmetry going right through there, okay? And what I notice is that, all these other points are equidistant to that line of symmetry and so on. So so this one has one and this one has one, but this one, no. Okay, let's take a look at another one. Okay, it says, which functions are symmetric about the y-axis? Okay, so here is our y-axis on all of them. Here's our y-axis. Here's our y-axis and our y-axis. And what we notice is that, this graph especially, we kind of just talked about this one, is symmetric towards the y-axis. We are equidistant to all those points. And so, we can kind of just tell by looking. This one, yes. Okay, yes. This one, no. Okay, this one is actually symmetric about the x-axis, but not the y-axis. Okay, and then this one, this up parabola going up. You notice that all these points are equidistant to the y-axis. Okay, so we have symmetry. All right, so let's kind of talk about your standard symmetric function is your simple quadratic function, f of x is equal to x squared. So, and what this means is that, as I look at this function, okay, here is my line of symmetry, the y-axis, okay, and what I know is that we are, 2 units away, at when y is 4, we're 2 units away. And then here, going the same way, we're 2 units away this way. All right? So, and that's the thing, is that when you can say here and you can go, okay, if I plug in f of 2, I guess that means that the bell is ringing for the middle school. Okay, if I plug in f of 2 into this function, I'm going to get 4, okay? If I plug in the opposite value, f of negative 2, then I also get 4, okay? And so that's what's kind of nice about this is that if I plug in a positive 2 or a negative 2, I get the same y value of 4, okay? And that's the idea. And that's where we lead into this idea of an even function. And an even function is something that is symmetric with respect to the y-axis, okay? And what we did earlier was we said, okay, if I plug in a negative x value, I should get the same thing as if I plugged in its opposite value, okay? And that's what happened up here, okay? It's the same idea, is that if I plug in negative 2, I get 4. If I plugged in 2, I also get 4, and so these things are equal. And we can say that f of negative 2 is equal to f of 2, okay? And all we're really saying there is that 4 is equal to 4, okay? Because we know that f of negative 2 is equal to 4, okay? And f of 2 is equal to 4. So these two things are equal, all right? And so what we want to do is we want to determine, are we symmetric? Are we an even function? So we want to determine if these are even functions. Now, what we've done over here with f of x is equal to x squared, just plug in a value, okay? And if you get plug in f of 2, all right, and, you're going to get 2 squared, which is going to give you 4. Okay, if you plug in negative 2 into that function, you get the quantity negative 2 squared, which is also 4. Because these are the same, because you get the same y value, okay, then you know that f of x is even, all right? If we come over here and we say, all right, well, let's try this one. Well, let's find f of, say, 1 and f of negative 1. So let me find f of positive 1 over here. So that means I'm going to get 1 squared minus 5 times 1 plus 1. Okay, which is going to give me 1 squared is just 1, minus 5, and then plus 1. Okay, 1 plus 1 is 2. So 2 minus 5, this gives us a value of negative 3. Okay, so f of 1 is equal to negative 3. Now let's plug in negative 1, and let's see what we get. Okay, so if I do f of negative 1, then that's going to give me the quantity negative 1 squared minus 5 times negative 1 and then plus 1. So negative 1 squared is going to give me positive 1. Okay, negative 5 times negative 1 is actually going to give me positive 5 and then plus 1. And 1 plus 5 plus 1 is going to give me 7. So f of negative 1 is equal to 7, all right? And so you have this value down here, and you have this value here. Okay, these are not the same. So since they are not the same, that means that that f of x here is not even. Okay, and that's how you can tell. All right, over here it says, which functions here are even? Check all the block boxes that apply. The ones that I know are for sure even is this one, okay? And I just know that graph is the V-shaped graph like this, okay? And so it's symmetric to the y-axis, all right? And the other one that I know for sure is this one, okay? And the reason why is because, on that one, if I take, all right, well, what's f of 1? Okay, let's plug in 1. That's going to give me 1 to the 4th minus 1 squared, which is going to give me, what is that? 1 to the 4th is 1, okay, minus 1 squared is 1, which just gives me a value of 0. If I plug in, say, negative 1 into that function, then I'm going to get negative 1 to the 4th minus negative 1 squared. Okay, negative 1 to the 4th, that's just going to give me positive 1. minus negative 1 squared is also positive 1, so 1 minus 1 gives me 0. So these are the same, all right? You get the same y value of 0, okay? And let's go to the next page. Okay, on this page, we need to talk about what's called rotational symmetry. And rotational symmetry means that the graph can be rotated. Graph can be rotated to get the same graph, okay? And so we want to take a look at each of these, and we want to determine, okay, which ones of these has rotational symmetry. And the ones that have rotational symmetry are the first one and the third one, okay? The second one, no, does not have rotational symmetry. And the reason why is that if you were to take these points here, all right, and rotate this graph around, you know, say 180 degrees about the origin, you would get the same graph, okay? Similarly with this one, if you were to rotate this graph around the center point of this ellipse, say 180 degrees, then you would get the same graph, okay? And that's the idea of rotational symmetry, all right? And so the way that you can tell just by kind of looking at a graph is by looking at some of the points on the graph. Here is the x value of, say, 2, okay, and it has a y value of positive 8. So you have this point here called 2, positive 8, all right? Now, if you were to come over here and, say, plug in negative 2, okay, what y value would you get? You would also get negative 8. So you have the point over here, negative 2, comma, negative 8. And so rotational symmetry means that you have these points on a graph that are symmetric to the origin, meaning that your x values, when you plug in opposite x values, you get opposite y values, all right? So, you know, you have the point here, x, y, and if the function has rotational symmetry about the origin, then the graph also contains the opposite of those. So that leads us into the discussion of what an odd function is. And before I do anything, let me do this, okay? On this function, when I plugged in, positive 2, I got positive 8, okay, as a result. If I plugged in negative 2 into this function, I got negative 8, okay? So if these are opposites, okay, if x and y are opposites, okay, then the function is odd, okay? Then the function is odd, and we can say that, is odd. Okay, not like odd like how I'm odd, but, you know, just odd, all right? And so, and that's the idea. And here's, by definition, here's what you get. F of negative x is equal to negative f of x. And what that means is that, you know, you plug in your normal value of 2, you get positive 8. You plug in a negative 2 value, the entire thing becomes negative, okay? So, you know, we can come over here to these examples and say, okay, which one of these is negative? Or I'm sorry, which one of these is odd? So if I plug in, say, you know, again, like f of 2, that means I'm taking 2 cubed, which gives me positive 8, okay? If I plug in f of negative 2, the opposite x value, then I get negative 2 cubed, and that's going to give me negative 8, because I'm taking negative 2 times negative 2 times negative 2, all right? Two negatives make a positive 4. Multiply that again by negative 2, and that gives you negative 8. So because these are opposites, then we are odd, okay? Now, let's do the same thing over here. Now, I'm going to plug in, say, negative 1 and 1. So over here, I'm going to say f of 1 is equal to 1 cubed minus 5 times 1 squared plus 2 times 1. Okay, and as a result, I get 1. 1 squared is 1, so minus 5 and then plus 2. So 1 plus 2 gives me 3 minus 5. This gives me a value of negative 2, okay? So I have that f of 1 is equal to negative 2, all right? So what I'm looking for is, you know, what happens when I plug in, say, f of negative 1? okay? So if I do f of negative 1, then I should really, if the function is going to be odd, then I'll get positive 2 out of this. So let's just see what we get, okay? And so if I do negative 1 cubed minus 5 times negative 1 squared, and then plus 2 times negative 1. All right, negative 1 cubed, okay, if you cube a negative number, you're going to get a negative value. So this is going to give me negative 1. Negative 1 squared is going to give me positive 1, so then just minus 5. And then 2 times negative 1 is negative 2, so negative 2 here. So I get negative 1 minus 5 minus 2. This is going to give me negative 8. Okay, so f of negative 1 is equal to negative 8. Now these values, okay, are not opposite. Not opposite. Therefore, it's not an odd function. Okay, and that's it. That's all we're dealing with. Okay. All right, so then it says check all the functions that are odd. I'll kind of let you guys do that. You just got to plug in values and see what you get. But I know that this function here is odd, and this function here is also odd. All right. Notice the exponents. Notice how the exponents are all odd here. Okay. Notice how the exponent is odd here, but you have this extra constant. This does not make it odd. All right. Okay. Over here it says the graph of the function is shown and has been hidden for the part where x is greater than 0. We want to complete the graph of the function if it is an odd function. So what I'm going to do here is I'm going to come in here and complete this. And I just want to identify some specific points that we will need on here. And so this is the point, we'll call this negative 2. Okay, what do we got? 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This is the point negative 2, negative 6. Okay? This is the point negative 4, negative 5. Okay? And then this point over here is negative 6, negative 6. Negative 6, negative 5. Okay? So as a result, what I want to do is take those points and reflect them over the origin. And what I would do is I would just flip the points around so that they are positive, okay, that they are the opposites. So if I have the point, negative 2, negative 6, the opposite point would be the point 2, positive 6, which would be up here, okay? And that'd be the point 2, positive 6. Notice how it's opposite. Okay, same thing over here. The opposite of negative 4, negative 5 would be 4, 5, which would be right here. All right, and then the point 6, 5 is right here. So this is the point 4, 5, and then this is 6, 5. All right, and so all I would do is then connect those points, and then they are symmetric with the origin, okay, because they are opposites. All right? All right, over here on this one, okay, it says the function f is shown in the graph is an even function. Okay, when it's even, that means it's symmetric with the y-axis. So symmetric to y-axis. Okay. The graph has been hidden for when x is greater than 0. Okay, so we need to complete the following sentence. So between 0 and 2, all right, on that interval between 0 and 2, the graph here between negative 2 and 0 is decreasing. If it was symmetric, then it would be increasing over here. So f is increasing, okay, over that interval. And then I know f of negative 2, okay, this point here is equal to 3. F of negative 2 is equal to 3. If we are symmetric to the y-axis, if we have an even function, then I know that f of 2 would also be equal to 3. Okay? All right, and then because between the interval of 2 and 5 over here, the function is increasing, that means that if we're talking about the interval way on the right side that we can't see, the side that's way over here, this would be decreasing. Okay? Decreasing. All right? Okay, and then the last one we're just going to have you guys, we're going to talk about that one in class. So just skip this one for now, and we'll talk about that one in class. So let's get started on the assignment and the quiz.